Welcome to problem 422 on page 167. Once again, we have a 2x2 table. This has to do with LinkedIn postings and B2B, or business to business, or B2C, which is business to consumer. So we've got a simple table, yes and no, increased LinkedIn postings, and broken down by the two major categories, B2B and B2C. So in part A, suppose you know that the marketer is a B2B marketer. So then in that particular case, we're only dealing with the first column. So it's given or known that it's business to business. What is the probability that he or she plans to increase LinkedIn social media postings? So in that particular case, you can see you take the 1266 and divide it by the 1947. We're only dealing with the B2B column. The other column is not relevant. So we wind up with 0.06502. So 65% is what it tells us. In part B, suppose that we know the marketer is business to consumer. What is the probability he or she plans to increase LinkedIn social media? So in this particular case, you take the 1625, which is the yes, from B to C column only, and you divide it by the total for the B to C column, 3779, and you wind up with 43% exactly. Now, we need to determine if the events are independent. So what we do is we take the probability that there's an increased use of LinkedIn, and I showed you the math on this because they didn't, where did they get the 50.49%? They took the 2891, which is the row that says yes, and they divide it by the grand total, the 5726. So in this case, you say the yes divided by the total of all responses for just over 50%. Now we've already calculated the second one, where increased use of LinkedIn, given that it's a B2B marketer. I showed you the solution, the calculation again, but it's the answer from part A. You get 65%. So in this case, the increased use of LinkedIn and business focus are not independent. If the numbers are the same, they're independent. If the two probabilities are not the same, as they are in this case, basically 50%, 65%, they're not independent. So if they're the same, they're independent. If they're not the same, they are not independent. And that's the end of chapter 4. Nice brief little look at probabilities.